Welcome to section 1.2. We're talking about graphing equations. We're going to be graphing lines, parabolas, and circles most of today. We'll do a couple of cubics, things like that. But we are going to use our graphing calculators, so please make sure those are out if you don't have them yet. Take a look. I am going to start with today's intro. I apologize. Just to start and make sure we kind of understand how many solutions and things like that. So if we give you the 0.34 and we ask you, is it a solution? We're going to plug the 3 in for x and the 4 in for y, and we're going to ask, does it equal 5? Well, 6 plus 4, does it equal 5? The answer is absolutely not. Okay? What about 1, 3? Well, 2 times 1 plus 3. 2 times 1 is 2, plus 3 does equal 5, so our answer is yes. And the last one, 2 times -4 plus 13. Okay, well, -8 plus 13, does it equal 5? Again, the answer is yes. Now, we could spend some time checking every single point if we wanted, but we are not going to. There are infinitely many solutions. This is a linear equation. The easiest way to show all of the solutions is to draw a graph. Okay, so that's what we're going to do in the next part, and we're going to talk about how to graph. The first thing you want to do is rewrite the equation so that one of the variables is isolated on one side of the equation. Again, we normally solve for y so that we could use our calculators if we wanted, plus it'll be in slope-intercept form. The second one we want to do is make a table of points. If you don't have a graphing calculator, this is going to be your way of doing it. Then we're going to plot the points on what we call a Cartesian plane. You guys also know it as a coordinate graph. It's the same thing, but I want you to know that word. And then the last thing, connect the points with either a smooth curve. Okay, and we're going to use that word, the phrase smooth curve, in case it's not a parabola, but it might be a cubic or something like that, or the most basic type of graph that we have, our line. Okay, so as we go through, please make sure you're following this procedure as you're going through, and we're going to start off by testing that. So let me move forward from here. All right, take a look. We have the graph 2x plus y equals 5. I'm going to start off by rewriting this in terms of y. So I'm going to subtract 2x, and I'm going to write my equation all the time in slope-intercept form. And we're going to spend all of section 1.3 on slope-intercept form, but let's start here. The second thing they suggested was to make a table. Okay, and you can pick any values you want. I'm going to do -1, 0, 1, and 2, just to name a few in case I want to just check out some extra points. Well, if I plug this in, -1 times -2 is 2, plus 5 makes 7. 0 times -2 is 0, plus 5 makes 5. 1 times -2 is -2, plus 5 is 3. And finally, 2 times -2 plus 5 is 1. And we're going to take these points and we're going to plot them. Okay, so -1 up 1, 2, 3, 4, 5, 6, 7, make a dot. 0 up 5, 1 up 3, and 2 up 1. And then we suggest to connect either with a curve or a line. And in this case, you can see that a line is the best way to do this. Biggest thing, they have to have arrows on either side. These arrows say that they go on forever and ever and ever. And so please make sure that you're doing the arrows without I will marks and things wrong, because we said above there are infinitely many solutions, and therefore you need to have the extenders to say that the lines keep going. Now, this didn't take too much time, but could we do it faster? Absolutely. If we were to put this in our graphing calculators, we could do it so much faster, and I want to show you that real quick, and I'll only do one, and then the rest you can do on your own. But let me pull up this calculator. And you'll notice this is the TI-84. The 83s work exactly the same way. I'm going to go to my y equals menu, and I'm going to put that equation in that we used before, negative 2x, and then plus 5. And it has to be in y equals form in order to use your calculator. If you hit graph, you will see that it'll align, but if I needed specific points, I'm going to hit second graph, and there's the table of values. And you'll notice these were the values that we had also. I mean, you see those same values, and so that could help you plot a point as well. And so keep that in mind as we're going through, that your calculator will make things much faster. Now let me get rid of this a second. Get back on our notes. I would like to do the next one, and I'm going to actually do it without a calculator, because as we've discussed before, half of pre-calc doesn't use a calculator, so I want to get you in that mode. If I look at x squared minus 4, they want us to graph it, and it's already in y-intercept form, which is wonderful, and then find some intercepts, and I'll show you those. But if I'm going to graph this, I'm going to make a table, and I'm going to pick a little bit more values, because we're dealing with an x squared, not just a line. So I'm going to pick from negative 2 to 2. Okay. If I plug in a negative 2 and I square it, I get positive 4. Minus 4 gets me 0. If I plug in a negative 1 and square it, I get 1. Minus 4 is negative 3. 0 squared is 0. Minus 4 is negative 4. 1 squared minus 4 is negative 3, and finally 2 squared is 4 minus 4 makes 0. And this is definitely enough points to plot our graph, so let's actually plot these points. Negative 2, 0, 1, negative 1, negative 3, 0, negative 4, 1, negative 3, and 2, 0. And this is not linear, so we're going to make a smooth curve. It is not jagged lines between there. Again, you need these arrows to signify that this keeps going on forever and ever. Please do not forget that. If we look at the picture, we can see that the x-intercept is where it touches the x-axis. And that occurs at 2 and at negative 2. It also occurs where the y value is 0. And I'm going to show you this algebraically, because in the next one you will have to do it algebraically. And so I'm going to let y equal 0, and I'm going to then solve to find the x-intercepts. So I'm going to add 4, 4 equals x squared, and when I square root both sides, please do not forget that you have a plus and a minus, and that's where the two intercepts of 2, 0 and negative 2, 0 occur. Okay, so these are my x-intercepts. In order to find my y-intercepts, the x value is going to be 0. And so if I plug that in, let me do it this way, y equals 0 squared minus 4. Well, 0 squared is just 0, so you get negative 4, which gives me a point then, when x is 0, of 0, negative 4. Okay? Algebraically, you will have to do on the quiz and the test also, so please be aware of that. I'm going to keep moving to the next one. We're talking about a cubic. They're asking you for the x and y intercepts algebraically. So let's start with the x-intercepts. And again, we're going to make y 0 in order to do this. So if I make y 0, x cubed minus 2x. Now, this requires some factoring. They both have an x in common, so I'm going to pull that out, x squared minus 2. And if I set both of these pieces equal to 0, my first x-intercept occurs at the point 0, 0. So there's my first x-intercept. My second x-intercept occurs when I set this equal to 0. So if I add 2 to both sides, x squared equals 2. And if I square root, I get x equals plus or minus the square root of 2. So my second and third x-intercept, I'm going to slide these over here a second, is the square root of 2, 0, and the negative square root of 2, 0. And so here are my 3 x-intercepts. The y-intercept, we said, occurred when x equals 0. Okay, so I'm going to plug that in. 0 cubed minus 2 times 0, well, 0 minus 0 is just 0. And if you look, that's the same point, 0, 0, as we had before. What that means is since it passes through the origin, let me write that actually out, passes through the origin, that it is basically both a y-intercept and an x-intercept. Okay? And so in some cases you will have it where it is both. In this case, again, because it goes through the origin, it is counted as both. The next part, we're talking about symmetry, and we're going to be using this symmetry the whole way through pre-calc. And so we're going to show you 3 types. The first type is x-axis symmetry, and let me draw a picture for you. X-axis means, basically, if I have a point here, which we call xy, if it's symmetric with this x-axis, then I will also have a point down here that is x negative y. Okay? So in order to test for if it's symmetric with the x-axis, we're going to test it by placing, instead of the y, we're going to put the opposite of y, or a negative y. If I get the same equation out, then it means it's symmetric with the x-axis. Let me show you y-axis symmetry. Okay, what it says is if I basically have a point over here, xy, if it's symmetric with the y-axis, then I'm going to have another point on the other side which has a coordinate of negative xy, and therefore you can see it reflects over the y-axis. And what we ended up doing is replacing an x with the opposite of x, or a negative x, and again, our goal is to get the same equation. So if you're trying to do a y-axis symmetry, you replace x with negative x. You'll notice the x-axis and the y-axis are both reflectional symmetries. And that's important because the third one is not. And so I want to point out that the first two are reflections over the x-axis and then over the y-axis. The third type is a symmetry about the origin. And the way the origin symmetry works is if I have a point up here, we call it xy, in order for it to be an origin symmetry, I'm going to draw this function here, I should also have a point in the third quadrant with the coordinates of negative x, negative y. And basically you'll notice that means it's got to be some sort of rotation. And so this is a rotational symmetry. Okay, and so the third type is rotation about the origin. What ends up happening is we replace both x and y with their opposites, negative x and negative y, in order to verify that I get the same equation out. And this stuff is so important, and we are not giving this to you. This stuff you must know. Okay, so maybe you want to make flashcards or something in order to be able to remember this. We're going to give you an equation in the next example and ask you which symmetry it has. So I'm going to show you how it works. Okay? And this one's asking you about the 3 symmetries, and it's asking which symmetry does it have. And so we're going to check them all. Okay, I'm going to start just in order like we did above. Does it have x-axis symmetry? Well, if it has x-axis symmetry, then we're going to replace the y with a negative y. Okay? Let's see if I can make this. So here we go. I'm going to start with the x, and instead of having y, I'm going to put negative y and square it, plus 4. Well, when I square a negative, it still turns positive. Did I get out the same equation that I started with? The answer is yes. Therefore, it has x-axis symmetry. Okay? We want to try the y. Even though one works, you still want to check all three. So the second one we're going to check is the y-axis symmetry. And if we're checking the y, we replace the x with a negative x. Apologize, my pen's not working very well. So here we go. Let's replace the x with a negative x equals y squared plus 4. Is this identical to what we started with? The answer is absolutely not. So this graph, this function does not have the y-axis symmetry. So we have one more to check. Let's check the symmetry with the origin. Okay, so if that's the case, we got to replace both the x and the y with negative x and negative y. All right, so negative x equals negative y squared plus 4. Let's simplify. Again, we said when you square a negative, it turns positive. Is this identical with what we started with? Again, the answer is no. And so this function only has symmetry with the x-axis. Okay, again, this is a wonderful quiz question. Please keep that in mind. We're going to give you a graph and ask you what type of symmetry is there. So please, please, please make sure you ask questions about that if you're not sure. The last thing we have for you is talking about circles. I'm actually going to change colors a minute so that we're on the same page here. Let me draw you a picture for a moment so that we can actually get the equation. If I look at a circle on this graph, the center, maybe, okay, this center is the point HK, where it has an x value of h and a y value of k. And there's some other point outside this circle, we're going to label it xy, as long as it's on that circle. And the distance between the center and the outside is r, the radius of that circle. Okay, well, with what we did in section 1.1, let's talk about distance formula or Pythagorean theorem. Either way, it doesn't matter. But let's do distance formula for a second. The radius would be the distance between this point and the center. And the distance formula says x minus h squared, so one value minus the second x value, plus y minus k squared. And to simplify this into the circle equation, we're going to square both sides to get rid of this square root. So r squared is x minus h squared plus y minus k squared. And this here is the equation of a circle where HK is the center and R is the radius. Okay, please make sure you can graph a circle because we're going to use that from here on out. So let's talk about graphing it and then writing the equation. Well, the center of this circle is 2, -3, so 1, 2, down 3. Here's my center. It says it has a radius of 4. That means from the distance to the center out is 4. And I'm going to use the 4 main points. I'm going to go up 4, and then I'm going to go right 4, down 4, and then left 4. And I'm going to make a smooth curve if possible. try and make this as best I can. Something like this. I hope yours is a little bit better than mine. This pen's not easy to write with. But let's talk about actually making an equation. The general equation says r squared is y minus k, let's try the other way first, shall we? Let's go x's and x's first. X minus h squared plus y minus k squared. Okay, well, we know r is 4, and we know the center is at 2, -3, so here's h and k. So x minus 2 squared plus y minus a -3, so y plus 3 squared. And I'm going to simplify this one more time. 16 equals x minus 2 squared plus y plus 3 squared. And here is the equation for your circle. Okay, tomorrow in class we're going to be working on all of this stuff and giving you different examples. Thank you for watching the lecture on section 1.2. Again, please make sure if you have any questions going along that you circle it and you ask for them tomorrow.